Hi everyone, welcome back again. So this was the question answer discussion part 2 video. We have the question I have discussed already in my part 1 video. If you have not seen, see that. And I will suggest you first go uh, to the chapter wise revision, then solve the questions, answer and see the answers, and then you can get it that which portion you are weak and which portion not. And when we are discussing the questions and answer, when you are doing the answers and when you are getting any answer, so, related to that, every point you try to note down, not only that particular answer, but related to that, any point if you are getting from your book, you note it down. Okay, so without wasting any time, let's get started. Name to artificial sweetness. Here, nothing to think, nothing to do. Here's a very good question. Not actually good. It's memory based question from the last chapter. That one is our that daily life, everyday life chemistry. Okay, and I would suggest you any question we're getting from this chapter. You point out the things also like artificial sweeteners. If I write any two name like alitame, and sucralose, Additime and sucralose, then you point out a few of the points like how we can form alitame, how much sweeter is that compared to sucrose. So these are the things that you have to point out. Okay, so this is quite a direct question that name to artificial sweetness. Next question we are having name to food preservatives. Now, if we go for the food preservatives, again we can see a few things that food preservative can be of two types. One type is when we are adding the food preservative that will create some type of conditions that if that keep the food the item good and that works against the microorganism which is bad for the food, and there are some food preservatives which we add to kill the that particular microorganism which makes the food which destroys the food actually. So if we go for the food preservative, if we go for the first type means bacteriostatic, that makes some condition to kill the bacteria enzyme that is not good for the food. So like this, one of the example is vinegar or citric acid. So I am writing here vinegar. Okay, and the other type is like we are adding particularly that thing to kill the food spoiling microorganism. So like this, the other type of example is bactericidal method. That one is sodium benzoate. We can write one example like sodium benzoate, and for sodium benzoate I will give more preference because this is particularly mentioned in the review that syllabus part in our that is given by the council. Going for the next question. Our next question is the rate of reaction. So this question is from chemical kinetics. As you know, chemical kinetics is very very important. Chemical kinetics, the knowledge, the calculations, the numericals are very very important. The rate of reaction becomes 4 times when temperature changes from 293 Kelvin to 313 Kelvin. So this question is from Arrhenius equation. As we know, the Arrhenius equation is rate constant equals to a pre-exponential factor e to the power minus Ea by RT, where Ea is the activation energy, R is the universal gas constant, and T is the temperature. Okay, so here it is told two temperature is given. That means we will take that simplest formula of the Arrhenius equation. That one is if we take ln K equals to ln A minus Ea by RT, we have to take. So we are actually that with the temperature, the rate of the reaction becomes 4 times when the temperature changes from this to this. Calculate the energy of activation of the reaction. So rate of the reaction becomes 4 times means rate constant. Actually, here it will be rate constant of the reaction. Rate constant of the reaction becomes 4 times. So we can consider this as ln K1 EA1. EA1 will not be because for the same reaction activation energy is same, so we can consider this as RT1, and for the other temperature we can write it like ln K2 ln A minus EA by RT2. So here is this. So if we take this to equation number 2 from equation number 1, then it will be ln K2 by K1 equals to minus EA by R 1 by T2 minus 1 by T1. So next we have to calculate the activation energy. What we know that rate constant of the reaction becomes 4 times. So ln 4 equals to minus EA by R. 1 by T1 is 293 Kelvin. 1 by T1 is and T2 is 313. 313 minus 1 by 293. So here we know 8 R value is 8.314 and we can calculate that easily. How? EA will become minus of 8.314 multiplied by ln 4 into 313 into 293 divided by 313 minus 293. So after calculation, let me know in the comment box what value you are getting, and I can check that there you are doing or not, because you have to do that also. I can do every answer, I can do the calculation, but if you make any mistakes while doing calculation, then the whole question will go wrong. So equation, that explanation I can give. So try this, do the calculation, and let me know in the comment box the activation energy value in joule per mole per Kelvin. And if you want to express in 18 kilojoule, then also, but mention the unit. Okay, let's go for the next question. Okay, so it is asked to give the balance equation for the following: ethyl cyanide, that is CH3 CH2CN to propanoic acid CH3 CH2 CO2H. It's very easy. If we hydrolyze this in presence of acid, then it will be converted into CH3 CH2 CO2H. If it will be ethyl cyanide to propyl amine, then we have to reduce it like with LiAlH4, then it will be CH3 CH2, that one is propylamine. So this type of conversion, and we have to follow the balanced equation here, though mentioned, but in case of organic, most of the time it will be balanced, so we have to see the number of carbons also. Acetamide to methylamine. So acetamide is CH3 CO NH2, this one is acetamide. Here too we are going to methylamine, that means CH3 NH2. So that one is degradation reaction, and we all know about Hoffman degradation. If we give potassium hydroxide along with bromine, it will go through the Hoffman degradation and will give you that methylamine. Okay, next question we are having, that distinguish between primary and secondary amine. This one we all know, Hinsberg test. Follow my nitrogen compounds video, here it is explained, so we can do that by Hinsberg's test. Okay, next we are having acetone and acetic acid. CH3 CO, CH3 is the acetone, CH3 CO2H is the acetic acid. And it's very easy, where we are having acid, by adding sodium bicarbonate we can get the effervescence, whether we can't get here. So by this reaction we can distinguish. So these are the few kind of reaction how you have to study following the specimen copy. Few reactions are here, few questions are here, and you can practice it, you can do the answer, and you can match it after that. And more questions I will bring in my next video. So if you want to practice that, follow my videos. And up to this for today. And if your friends are also preparing for the same, please do share with them. And if you have liked this video, then like it, and don't forget to comment, and thank you for watching.